And in today's lecture, we are going to discuss about Newton's ring experiment, or you can say the theory of Newton ring experiment. First of all, understood Newton ring is an experiment of interference. Basically, there is nothing; it's a just interference. Okay, so you can see the experimental setup of Newton's ring experiment. Okay, here we have a source. Basically, we use the monochromatic light here, but instead of monochromatic light, we can also use white light. If we use white light, what we got the colorful rings out here, nothing. Okay, and one of the most important thing about the Newton ring experiment is that at the center we get the dark fringe, or you can say at the destructive interference at the center. Okay, why this happen, I will tell you later on. So this light source produce a light, monochromatic light, and this light is just concentric by a lens, converging lens. So this after that there is a glass slab. So when this light incident on the glass slab is reflect, okay, and when this light reflect on the surface, this is a plane convex lens. Okay, this is a plano convex lens, and you can see this is O is the center of the plano convex lens, you can see. And also here in this region we got another lens, you can say, and in between this there is a air, okay, for which the refractive index is 1. So now what happened when light incident, I'm just taking this part. So when light incident on the surface, okay, this part, this air film, you can say, so some of the light is reflected from the upper surface and some of the light goes below and reflected back, and these two rays R1 and R2 coincide with each other or superimpose with each other and produce the Newton's ring. Okay, so correspondingly there are reflected rays. So basically this is a kind of interference between the reflected rays. So in class 12th you study about reflection from a glass slab. Okay, so it behave like the same. Okay, this is a glass slab, light, this is your normal. So light incident on the surface, from upper surface light is reflected. Similarly some of the light goes to the lower surface, is reflect back. Okay, and R1 R2 superimpose with each other and produce the interference pattern. Now one thing more you need to remember, the rays R1 and R2 have a path difference. Okay, we already know this. The path difference between the rays R1 and R2 is nothing but 2 mu t. T is the thickness. Okay, here you can say T is thickness, here the T is the thickness of slab, mu is the refractive index. 2 mu t cos R in generally, or plus sometime theta. Okay, plus lambda by 2. Why there is a lambda by 2? Because there is a basic fundamental principle of optics is that when light is reflected from any dense surface, see below this there is a dense surface, above this there is a rare surface. So when the light is reflected from a dense surface, there is an extra part difference of how much? Lambda by 2. Okay, so now the part difference between the two rays who producing the Newton's ring, okay, or who just interfering with each other, have a part difference of 2 mu t cos r plus theta plus minus lambda by 2. Since the rays are incident normally on this, on this plano convex lens, so you can say r is 0 and theta is very small. So this value is become 2, mu is 1, because this is air, there is a air surface here, I told you already. Okay, there is a air surface between this, so this is air. Okay, so then we got the part difference 2t plus minus lambda by 2, or we generally say 2t plus lambda by 2. Okay, so this is the part difference, and at the center, at the center what happened, the thickness becomes 0. So as the thickness becomes 0, the part difference between the two rays become how much? Lambda by 2. So and lambda by 2 is the condition of destructive interference. So that's why at the center of Newton ring we always get a dark fringe, or you can say we always get a destructive interference. So I hope every one of you understood till this point. ठीक है, यहाँ तक आपको समझ में आ गया होगा. Now we talk about this Newtonian ring. So let's say this is the Newton ring. Okay, the formation of Newton ring is like this. So here is the Newton ring forming. So this thickness is t. Now we taking this surface, okay, this curved surface, and if we complete this sphere or the circle, you see the radius of curvature of this surface is how much? R. So the total distance from here to here, this is center O or somewhere. So this distance from here to here is r, and this is r. So this is your diameter of the circle. Okay, we complete the circle. Okay, we got the diameter 2r. Also this line is behaving as a chord. This line is behaving as a chord. Now there is a property of circle, you know, when two chord intersect each other. See, these are the two chords which are intersecting each other. So the intersection ratios are same. So that means if you multiply db plus b, it equal to AB plus AB into BC. So this is the property of what? Circle. Okay, this is the property of circle. Now from this property, since this is R is what? Radius of Newton ring. See, this is here we know we get so many rings like this. Here we got so many rings. So R is radius of Newton's ring. So we got a formula R square equal to 2RT into 2 square. Since this thickness is very small, okay, it tends to 0, so we neglect this part. So what is the value of r square? R square equal to 2r into t. So from here you can easily find out t equal to r square by 2r. What is the capital R? Capital R is nothing but radius of curvature of this plane convex lens, and small r is radius of Newtonian rings. Okay, now we need to find out the now what I am finding, I'm just finding, okay, I just need a blank page out here. Just I'm taking here, just see. So now we know the condition of constructive interference. So the part difference for, I'm just taking it, just see please. Okay, for bright fringes or rings, the part difference, how much is the part difference? 2 mu t plus lambda by 2 must be equal to n lambda. So from here 2 mu t is equal to 2n minus 1 lambda by 2, and you can put the value of t. So 2 mu r square by 2r. I hope this the value we get here. See, this value of r square t is r square by 2r. Put here is equal to 2n minus 1 lambda by 2. So once we solve this, okay, from here you can easily find out the radius. So how much is the r square? R square is nothing but lambda by mu, 2 mu, 2n minus 1. Okay, so from the radius of nth Newtonian ring is nothing but lambda by 2 mu, 2n minus 1. So here we can easily find out the diameter also. Now move on to the second part. So this is the radius of bright fringe. Simply radius of dark fringe, dark ring. Okay, so for condition is 2 mu t plus lambda by 2 is equal to 2n plus 1 lambda by 2. This is the condition of dark fringe. So lambda by 2 cancel out. So you got 2 mu t is equal to n lambda. Okay, put the value of t out here. So you get 2 mu r square by 2r is equal to n lambda. So again 2 to 2 cancel out. So r square equal to n lambda r by mu. Since mu is 1 for air, I already told you put the value of mu equal to 1. So radius of nth bright ring is how much? Under root n lambda r. So radius is half of the diameter. So you can see lambda by 2 is equal to under root n lambda r. So once you solve it, what you get? You get the diameter is nothing but under root, take it inside the root, 4 n lambda r. So this is the diameter of nth bright fringe in, or nth bright ring in Newton's ring experiment. Okay, so everyone, I hope you understood. Now come to the application part. So till here you understood how we find out the diameter of dark ring. Now what are the application? See, the first application is to determine the wavelength of monochromatic light. The experiment, the Newton ring experiment we do to find out the wavelength of mercury light or any monochromatic light. So from here the formula of nth dark ring, radius or diameter of nth dark ring is dn square equal to 4 n lambda into r. N is the order of ring. Okay, now if nth ring is diameter 4 n lambda r, nth plus p ring have a diameter 4 n plus p lambda into r. Just subtract these two. subtract, we can able to find out the lambda. So what is the lambda? Dn plus p whole square minus dn square upon 4pr. So this is your value of lambda, or you can say wavelength of monochromatic light. So similarly, if you want to find out the refractive index, okay, you want to find out the refractive index of any liquid. So since for air, and when there is a air in between this region, the diameter of n at dark is 4n lambda into r. But if you fill any liquid out here, let's say I'm filling a liquid out here, then what is the diameter become? 4n lambda into r upon mu. So once you divide this, you got the value of mu. So dn air square upon dn liquid square. So this is the basic formula to find out the values of so many things. So anybody having doubt, you can ask. Thank you everyone, take care, bye.